The human brain is a marvel of creation, intricately designed to seek meaning and connection. During Ramadan, this quest for spiritual fulfillment is heightened. Fasting activates areas of the brain that are associated with empathy, self-control, and reflection. Join us this Thursday at 6:15 p.m. for an enlightening lecture by Dr. Daniel Abdulrahman McBride on the fascinating connection between the brain, religion, and Ramadan.
The term autophagy, autophagy, that's when your body, if you fasted long enough and if your body's hungry enough, what happens is your body starts consuming, generally speaking, it starts consuming itself, auto, and phagy is eating. So what happens is when you move into that, whatever it is for your body, when you move into autophagy, it starts cleaning out injured cells. It starts cleaning out bad cells. Everything ramps up in terms of getting healthy. Your body is going to self-eat, self-clean when it's self-eating in this case, okay? It's not a disease. It's not an autoimmune process. It's literally when you fasted long enough, your body goes into overdrive, and this term autophagy is really, really cool because fasting, it's all these little subtle things that Allah didn't explain to us, but science is only discovering what Allah has already put in place, if I can say it that way. When we talk about the word discovery, it's already here, right? Because we found it. So we found that the body moves into a state of autophagy and helps clear out injured cells, dying cells, older cells. It speeds up the replacement process, and it helps clean out unwanted cells, including cancer cells in a lot of the research. So autophagy is really important, and fasting is the way to move it into a good sense of overdrive. So today, I'd like to remind everyone of last week's talk. Last week, we talked about the frontal eye field, and the reason I start there is because what you look at is what you're going to pay attention to. Your eyes lead you into almost everything, good or bad. And what are we told as Muslims? We should always lower our gaze all the time. Why is that? We don't want to look for haram, all right? And as a side note, when you lower your gaze, when you look down, that stimulates your parietal lobes, gives you more spatial awareness, and it tends to stimulate more right brain than left brain, which makes you more self-aware and aware of others, makes you more social. So even glancing down has all these subtleties that we learn about in functional neurology and brain function. And I started there because what you're looking at is what you're going to be focused on. And that's what you pay attention to. And again, if I can, one of the big reasons I think that's so important is one of the first thing the Prophet ﷺ was told, the first word in the Quran is Iqra, or read. And how do we read? For most of us, we read with our eyes. If you're using Braille, I'm cool with that too. It's still read. And research is now showing that reading books and reading and writing, and what are we also told? We were taught with the pen, writing. We weren't taught with a keyboard. It's efficient, but it doesn't stimulate as many neural pathways. It doesn't stimulate, they've shown it on MRIs and QEEGs, that when you're reading and you're writing, or you're listening and writing, when you're taking notes, you stimulate more brain, and you make your brain work harder or work better, more efficiently. You train it in. When you're reading, when you're writing, especially when you're writing, because typing doesn't stimulate the same amount of brain function. That's more habitual because you're finding the keys and you're not stimulating as much motor function as you are with writing, and the same memory things about letters and stuff. So I started with frontal eye field because focus and attention. Now what I'd like to do is we're going to talk about the motor, premotor, and supplemental motor areas. And we're going to talk about the dorsolateral prefrontal cortex. Your motor areas right here are going to be 4, 6, and then you've got you got premotor areas, part of 8, supplemental motor areas. They even blend over into something. Some researchers consider your speech areas. That's a motor function and a premotor function. You've got verbal planning. So you've got premotor, right? You're planning on what to say. Your body's preparing what words, what muscles to use to deliver the words. So you've got your motor just in front of the halfway point. You've got your motor, premotor, and supplementary motor areas. You can consider associated motor areas. And that's all about the action steps that you are now initiating. And what's really cool about that is right in front of that is your dorsolateral prefrontal cortex. That's where, if you remember from what we talked about the other day, that is going to be what we consider your big word, or not clearly defined word for most of us. Your dorsolateral prefrontal cortex is going to be your executive decision making. That's where you are going to start. That's where you're going to finally, and with your prefrontal cortex up this part of it too, you're going to finally decide to do it. Left side, right initiation, or right side inhibit and not do it. Or if they're working together, which we hope all of ours are, if they're working together, I'm going to initiate an action. And what I want to do at the same time, that's why it's not just when people talk about the laterality and the whole brain lights up and they're all doing the same thing. That's not true. Because I'm initiating and I'm following through with my action. Getting here, turning on my computer, those are all initiating. I'm talking right now. My right brain at the same time is, and I kind of squirrel out sometimes. So my right brain is inhibiting all those other squirrely thoughts. So yes, both sides. And then of course you've got putting words together and putting thoughts together. So my right brain is active, but at the same time, most verbal stuff is coming from your verbal, most of us. I think it's like 96% of us. It's a gigantic number. Almost everyone's verbal centers are on the left side. Your Broca's area, your Wernicke's area, that's where you do all of your speaking and understanding, but this is the big picture side. So while I'm talking, while I'm listening, while we're sharing ideas, you're actually stimulating complementary word and verbal functions on the other side, but that's the big picture comprehension side of it, if that makes sense. But at the same time, while I'm initiating all these thoughts and I'm trying to focus on just my dorsolateral prefrontal cortex and my motor areas, I'm focusing on those two today while I think about my frontal eye field, while I'm thinking about my orbitofrontal cortex, while I'm thinking about my anterior cingulate, right? But I've got to inhibit talking about those because I want to focus on just this. So I'm initiating from the left, and the motor areas involved are obviously my speaking motor and, of course, using my hands. And the more hands you use, believe it or not, the hands and the ability to write improve with your verbal centers at the same time. It's a really some cool pathways. But the better you are verbally, the more, when we talk about fine detail, motor skills, our verbal skills, and then handwriting. And of course, holding like this rather than like this. And there's tests we do for that. But the idea is your verbal centers and those fine motor skills, right? The premotor, supplementary motor, and the motor centers, right just in front of center and a little bit over here, as I said. Those are all initiating and inhibiting initiation actions. Then the dorsolateral prefrontal cortex, actually the executive functions. Now, this is what I am decision making about. This is Left side would be planning the steps I'm going to take to do this. Prepare the talk ahead of time. And I actually have things written down just in case I forget something, just in case I lose track. But I highlight my key points, and they're here to remind me what I want to talk about. So what you have is, and I'll read it to you. It's really cool. Dorsolateral prefrontal cortex, the highest level of thinking and planning. And what is that right next to? Right next to the motor centers. So the highest level of thinking and planning is right here in the frontal eye field, is right in that area right there also. Okay. So what you have is where all of this motor action, planning action, and eye function, also motor action, all of this is right here next to each other, so that it can be done, like you say, like you can see, within milliseconds. The words pop in, they come out. Yes, it makes sense. Hopefully, it comes out. And it's really cool when you think about it. This stuff doesn't just evolve and develop. I mean, we can talk about that. And I know my evolutionists they're really on that stuff. And they can probably explain a lot of hypotheticals. But the idea is planning this stuff out, laying it down, creating us makes much more sense to me, and as Muslims to you also. Evolution is a cool idea, and I can accept adaptation. Your bodies adapt all the time. As we age, it's harder for us to put on muscle, for example. It's a big thing, exercise and muscle. Well, when I was in my teens and 20s and 30s, I could see rapid changes up and down literally within weeks of changing protocols, my exercise protocols. Now it's not as easy, but I still put in the effort. And it's really cool because your body as it ages also adapts in a lot of good ways. So I'm not complaining. It's just really cool. So I'm a big fan of adaptation, but to say we evolved everything on earth, the trees, the grass, you and me, not just animals coming from the same source, but understand what they're saying with the theory of evolution. We all are supposed to have come from the same single-celled organism, and eventually it broke into multiple cellular organisms. Then it separated and broke apart and became different organisms. Then it developed into a blade of grass and you and I. So for me, that whole evolutionary part doesn't make sense. Only the main reason is because there's nothing more efficient than single-celled organisms. And usually the argument for evolution is smarter, stronger, right? Well, that's not the case. Smarter to initiate and avoid, but we're not stronger. If you threw us, if you remember what they used to do in Roman times, and everybody brags about Roman history, man, we know they used to throw people to the lions. And how many single combat things, except in movies, right? The lion's going to always win, isn't he? Or she, for that matter, the lioness, they'll always win. Doesn't that make sense? So smarter is better, but at the same time, we've got to understand single-celled organisms are more efficient. You can research this stuff now. You can look it up on the internet with whatever search engine you want to do. Evolution and single-celled when you've got bacteria, when you've got viruses, you've got all this stuff, they adapt and mutate quickly. Think about it. If it takes pretend it's only one generation with bacteria and viruses, we're talking about this fast. Within 20 minutes, in some cases, you've got a whole new generation. Human beings, we're talking generations. We're talking about reproductive ages in terms of teens, right? We're talking a decade or two. And picture that. Imagine now the adult has to survive long enough to train in the child. So it's even more than one generation. It's even more than teens and 20s. We imagine the minute you hit reproductive age, now how smart are you, number one? And number two, how much longer do you have to live and your child has to live so that they can learn enough to survive and reproduce and teach it to their children. Does that make sense? So for me, this evolution thing doesn't make sense based on efficiency and the likelihood of living long enough. And there's too many missing links. We all know that. So I'm a big fan of creation, and this is why. And the brain itself, the fact that all of this stuff works in there and the way it connects, and we won't even get into that. And now I've got to turn my right brain on and inhibit the distractions I'm using. So the idea is, think about it. With the dorsolateral prefrontal cortex, if you are making, and we talk about treatments and stuff, if you are making decisions, and pretend the whole decision is good, right? You get this big idea, and there it is. Your right brain says, man, I've got this great idea. And then now I've got to push it over to the left dorsolateral prefrontal cortex. Yes. And these are some of the steps I make. And then I push it back to the motor areas, right? Or maybe it's frontal eye field and that part of the motor area and the motor areas. I'm going to go to the library. I'm going to get a book, or you can get it on the computer stuff through certain apps, and you can access all kinds of library books, right? So now you got to push it over to the left to then initiate the actions that you need, and you need to focus your attention on that. Those three fields by themselves, right? So imagine if you're real good at coming up with the ideas, but you've got no follow through. Well, then what I want you to do, really cool, because I want you to involve your eyes again. And again, what we're going to do is modify what I told you the other day for left and right. And that's why I started with hemisphericity, understanding left and right. What we're going to do is we're going to focus on, if you have a problem initiating, we're going to focus on the left side, which means what? If we're doing, remember saccades and anti-saccades? Saccades are when the finger wiggles. Let me come over. I'm going to turn this a little bit. So imagine when the finger wiggles, you want your eyes to immediately flick to the wiggling finger and then come back to middle. The other finger wiggles, you look there, come back to middle. And this takes a partner because I know what I'm going to do, right? So the partner wiggles the left, you look at it and come back. Wiggles the left, you look at it, come back. Wiggles the left, you look at it, come back. Then they wiggle the right, you look at it and come back, right? Wiggle left, look at it, come back. And you make it as random as possible so that it is truly reaction and frontal eye field and immediate initiation from the opposite frontal lobe. So if I'm trying to train out the left with a saccade movement, or train in the left with a saccade movement, I'm going to want to wiggle the right, in my case, the right thumb more than the left thumb, okay? So I might wiggle, look, wiggle, look, wiggle, look the other way, wiggle, look back, wiggle, look back, wiggle, look back, wiggle, look, wiggle, look, wiggle, look, wiggle, look, wiggle, look, wiggle, look. Does that make sense? So what you're doing is this frontal lobe, the whole frontal lobe that we're discussing, all 5 subcortical regions, when you're doing a saccade over, when you're doing that saccade action, you're literally stimulating this whole left side. You're stimulating the motor area, premotor, supplemental area. You're stimulating the frontal eye field because you're using vision. You got a little bit of motor with the, well, not you, they would. Okay, you got the motor with the eye movement. You've also got the dorsolateral prefrontal cortex, right in this area, that's making the decision, go, follow the directions. It said when that thumb moves, you got to look at it, you got to look at it, you got to look at it. When the other thumb moves, you got to look at it, you got to look at it. Then back here, because we're focusing on left in this example. So what you're doing is you're stimulating that whole side. And then, of course, you've got your anterior cingulate, we'll talk about next time, and the orbital frontal cortex, which we'll talk about next time also. Those are more in terms of social skills, and the anterior cingulate will be motivation, but we'll talk about that next time. But you're also doing some anterior cingulate because you got to be motivated to want to make that improvement, right? So literally with the dorsolateral prefrontal cortex, it would be cognitive function, it's executive function, it's planning, it's goal setting, and inhibiting unwanted goals, thoughts, and actions. Fine, detailed motor skills. Another thing, like I said, I wrote it down for a reason. Believe it or not, reading out loud helps target the dorsolateral prefrontal cortex. Just like this kind of thing, the saccade movement, it's stimulating your frontal eye field, your motor centers, and your dorsolateral prefrontal cortex. You're also doing, when you read out loud, what did we just talk about? Fine motor skills, verbal centers. Yes? So you're really targeting a lot of left hemisphere when you read out loud. Not only do you have eye movement, you have reading out loud, you have mouth and motor movement. You also are stimulating your verbal centers. If you're reading out loud and there's a message or a theme, your right side is stimulated, trying to figure out why the author did that, why the characters did that. Reading out loud is a great, fine, detailed dorsolateral prefrontal cortex motor area and frontal eye field activity to train that stuff in, okay? And it would actually be both right and left in that case. And it's really good, almost forgot, believe it or not, memory, because you've got to remember what the words are when you read them. Your eyes, your brain reads in blocks. It recognizes. That's why I always laugh when I see these tests. And before I knew that, I used to take them all the time. It'd come up on your computer and it'd say, if you can read this and you've only got the front and the back letters that are correct, if you can read this paragraph, you're a genius. Well, most people can do that. Well, hopefully we're all geniuses then. But the idea is your brain reads letters and words in blocks. So it looks at the whole word. Once you learn things, it looks at the whole word. You don't need to sound everything out again. So the more you read, the better your memory and the better your reading skills will be. Honestly, the more you read, the more words you pronounce correctly, the more memory, the more basal ganglia, the more automatic it becomes, the better your brain is functioning. Okay. And literally reading out loud, such a fine motor skill. Some people can't pronounce anything. So think about how hard your brain is working to pronounce things correctly. When my computer guy and I are talking, he says something in, if I say something in Spanish, of course, I stumble through it because I'm not used to it, but I try to get the pronunciation correct, fine motor skill. And then some of the things, because he literally grew up in Puerto Rico. He is original, his main language is Spanish. So when he's trying to pronounce the English pronunciation, we have a good time with that. He's laughing at my horrible Spanish, and his English is better than my Spanish, though. But we have a good time with that. But that's because it's a fine motor skill and you're training it in. That's why learning multiple languages is just brilliant. And we should all teach. I wish I would have known this when I was raising mine. We should all teach our kids a second language. Mine were learning Arabic. I just didn't realize how powerful an engine it was to drive brain function. Research shows if you grow up, if you speak 2 languages or more, if you speak 2 languages, you get a better comprehension of both of them. They did it on Mexican kids coming in when they spoke Spanish at home and English at school. First grade, they were usually behind. By second grade, they had almost caught up. By third grade, in an English-speaking school, they were literally, their comprehension skills tested out better in English and Spanish than singular English-speaking kids of the same age. So in 3 years, in a good school, in an equal environment of education, right? They were behind when they first started, but then they started to catch up. And literally the research showed that by third grade, studying the same, equal, nothing excessive, equal, by third grade, the majority of the children had caught up and surpassed their English first language classmates because they had 2 and they looked at it not just from 2 hemispheres, but they could look at it from 2 different perspectives in terms of sentence structure and everything else involved. So reading out loud and reading is huge for brain development. And again, reviewing this, you've got the dorsolateral prefrontal cortex. That is your executive function, your decision-making, your planning, both initiating and inhibiting. That's fine motor control, especially your language centers, the dorsolateral prefrontal on the left. comprehension on the right, big ideas on the right, understanding the whys, moving it over to the left so that you can verbalize it as a fine motor skill, right? And working out the details. And really important, dorsolateral prefrontal cortex, because the more understanding you have of something, the better it is stored in your memory centers. And remember your hippocampus. I've mentioned that before, I'm sure. When you start to have hippocampal dysfunction, and we talk about Alzheimer's and dementia, there are other ways to stimulate memory. It's more and more research is saying that the hippocampus is what I talk about as a memory janitor. It remembers where things are. But say it's a musical memory, it's a reciting Quran, and that stimulates coming in from the auditory centers, that stimulates a different pathway to that same definition, or that same, I memorized this under so-and-so, or my mother taught me this, that kind of thing. Here in America, they're using a lot of, and all over the world, I'm sure, they're using a lot of musical therapy for memory, because songs, and I told you the story before about the grandmother who lost her ability to speak after a stroke, and they just had her sitting by a window, and a granddaughter came in, said, at least let's play her favorite songs on the radio. And the grandmother, for the first time in a year or more, had started singing with the songs, and everybody was floored. So then the doctor came in and said, oh my gosh, let's start using that all the time. And she regained her verbal skills. And they brought it in through the auditory pathway rather than straight memory and trying to recall the words. They stimulated it through a different pathway, which was auditory. So all of these connections are important, and especially how the frontal lobe functions. And in this case, like I said, dorsolateral prefrontal cortex with memory centers. So the stronger this is, and I just gave you a action for that, the test, we've got saccades, anti-saccades, and for hemisphericity, I'm going to teach you another test right now. But that's why all of this prefrontal, or this frontal cortex, this forelock, as it's mentioned 3 different places in the Quran, and in particular, Surah Al-Kahf, is that 96? 96 verse 16. No, that's another of my favorite verses. But I believe the number is 96. No, El-Alaq. I'm sorry, El-Alaq. 96 verse 16, lying, sinning, forelock. If they're a liar and a sinner, they're initiating, but they're not inhibiting. And that is the area, especially with the dorsolateral prefrontal cortex, right? That's where you're going to actively executive decision, make the decision to be a good Muslim or a bad person, right? As the sister was talking about, you really have to own in your brain, and then orbital frontal cortex will come into that, what you believe, and then what you do. Because the orbital, and I'll just preface next week's talk, the orbital frontal cortex, you may be able to theoretically tell me, yes, I would do this. Yes, I would do that. No, I certainly wouldn't do this. But then I had a patient do that. No, I'd never hire a rapist. I'd never hire somebody convicted of sexual assault. I'd never hire somebody who's convicted of fraud and lying. And then I said, well, why would you vote him in as president? If you're not going to hire him as an employee, why would you hire him to be your president? And that's where her right side was good, but her left side, the initiation was not there of her moral code, because she's a great person, but she voted for this choice that she made, which I totally disagree with. So that's where that decision is made in the orbital frontal cortex. There's a lot of, that's where you tie in your social, your moral, and bring it over into action. And we'll talk about that next week. The more you understand about yourself and really understand that is, if you can control your thoughts, if you can control your brain, you're in control of everything. I mean, you are, without implying that we're taking a part of God's power. That's where you can create everything, with Allah being the true creator. That's where you will access all of your potential. And of course, some people will say, they'll say, oh, you can't control your thoughts. I got to tell you, that's the one thing you can control. Because right now, even if I was a little bit boring, you still paid attention to me and you tried to inhibit the thoughts of paying attention to something else. It's literally, if there's one thing I want you to know you can control, it's your thoughts. There's no exaggeration. I just don't think they put the neurology into it when they talk about positive affirmations. It is positive thoughts. It is thought control. It is, you hear something good or you hear something bad, it's automatic to say Alhamdulillah, Alhamdulillah, right? Something goes bad, astaghfirullah, astaghfirullah, astaghfirullah. You make a bad decision, oh my God, astaghfirullah, astaghfirullah, astaghfirullah. Somebody says something nice to you, mashallah. Somebody sneezes, they say Alhamdulillah, it's automatic, right? We boom, boom, boom. We say it, they say, and then we say something. I mean, it's these steps we take, isn't it? So these are things that you train in. So I'm telling you, as a functional neurologist and as a friend, I hope, through the computer, the idea is if there's one thing you can control, it's your thoughts. And that's what we are teaching by talking about these different areas, because to control your thoughts, you want to control what you pay attention to. Frontal eye field, we talked about why. To control your thoughts, you want to control your decision-making. Dorsolateral prefrontal cortex, initiation on the left, inhibition on the right, yes? And then motor, you're going to decide what you're going to do. Then you're either going to not take an action, inhibit and avoid haram, or initiate action and initiate halal, right? And this is the brain, this is the area, it's neurological that you can, it's functional, it's you, Allah blessed you with the ability, you can control your thoughts. If there's nothing else you can control in your life, you can control your thoughts. And then we discussed, like I said, hemisphericity, good and bad, training in the good, training out the bad, to do that. And then here's a real cool for either side, okay? As I mentioned, we were trying to strengthen the left a moment ago, so I'll do that again. What you're going to do is you'll be here, and you'll have your fingers out like this for a reason. What you're going to do is when this finger moves, boom, 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 right? Your eyes jump to that finger. So the person helping you, that finger wiggles, so my eyes jump to it. Now, I'm going to teach you a parietal lobe exercise. The frontal lobe pushes to the opposite side. Now I'm going to take this finger, I'm going to bring it over here. Now my eyes are going to follow that finger back to the starting point. That is your left parietal lobe pulling it towards that finger. So then what you do, and if you're working by yourself, you don't even have to wait for the wiggle. You jump to it and then pull it back. Jump to it and pull it back. Jump to it and don't look at the thumb till it touches. Now you jump over and pull it back. Jump to it, pull it back. Does that make sense? And then if you were going to do the right hemisphere, to be nicer, to inhibit. If you're a person that blurts out all the time, if you can't control your emotions, then do a right hemisphere. Now you want to do inhibition. So what I'm going to do is I'm looking at this finger because I'm going to stimulate this side, my right side. I'm going to look at this one, then I'm going to jump to the left, then pull it back to the right. Push to the left, I should say, because you're pushing with the frontal lobe. You're going to, okay, I'm here. I'm going to push to the left, pull it to the right. Push to the left. I'm failing. I'm going to push it to the left, pull it to the right. Push it to the left, pull it to the right. Push it to the left, pull it to the right. And we're using all three of the areas that I just talked about. And then we're targeting hemisphere. So remember, the frontal lobe jumps or pushes, that's your saccade. And then your parietal lobe pulls it to the same side. So if you're doing left, you're doing saccade, pull, saccade, pull. If you're doing right, saccade, pull, saccade, pull. Does that make sense? And if you have any questions, ask me and I'll do all the silliness, all the testing again. And this time I'll get it right. So if you have any questions, feel free to ask.